Welcome to the second video in the Unit 6 Projectile Motion series. This video is going to cover pathway number 1, in which case objects are shot or fired horizontally and follow a half parabola shape. What this video is going to consist of is 4 problems. I'll work through the first 2, and then the last 2 I will let you do on your own and check your answers. So let's take a look at this first one. A ball rolls off a table at a velocity of 3 meters per second. If the table is 1.2 meters above the ground, A, how long is the ball in the air for? B, how far away from the table will the ball land? And C, what is the final velocity horizontally, vertically, and then what's the final velocity total? The first thing you want to do before you do any of these problems is you want to draw a picture. You want to get a good picture to work off of. So I'm going to have my table right here, and I'm going to draw my ball on top of the table, okay, and the ball is moving at 3 meters per second, and I know the table is 1.2 meters off the ground, and then once the ball goes off the table, it's going to follow this sort of pathway right here. And so what we want to figure out is A, how long is it in the air for, so what's the time? B, what is the distance from the table the ball will land? And then C, what is the final velocity? Now, it's important to know that the final velocity is going to be diagonal. When the ball was shot off initially, it was all horizontal. But as time goes on, at the very end, the velocity at the end is going to have an x component and now also a y component as well, because the ball was increasing speed in the y direction as it went. And so if we were to do a vector addition of that, let me draw that again, a little cleaner. Okay, so when it lands, once again, it has x velocity. It's going to have a y velocity. And so if I do vector addition, it actually will have a final velocity that ends up being diagonal. And that makes sense. Now, what's very important to know before we get into the problem is that the final velocity is not 0. Sometimes students think the final velocity is 0 because it hits the ground. But you got to think, once it hits the ground, now that's a whole new physics problem. That's collisions. And we haven't covered that. So when we say what's the final velocity, really what we're asking for is what is the velocity the second or moment right before it hits the ground. So that's what we're going to solve for. So the first thing is draw our picture, which we've done. The second thing we want to do is we want to write out our XY table. The reason why I'm drawing an XY table is because in projectile, there's 2 motions going on at the same time, X and Y, and we need to split that up. So we have our X component and our Y component. And if I think about all the kinematic equations we've ever used, the variables that we've come across is V initial, V final, acceleration, time, and then displacement. So I'm going to write those off to the side. And what I'm going to do is I'm going to fill in what are the X components and what are the Y components. It's very important in projectiles that you make sure you understand that we have to treat X and Y separately. Once we've got them separated, keep them separated. Do not blend them together. All right, let's go through and see if we can figure out some information that we already know. Let's start off in the X column first. So I want you to completely forget about Y for just a second. In the X direction only, what was the initial velocity? Well, we know that the initial velocity was horizontal completely, and that it was 3 meters per second. And since we've already talked about how in the X direction there are no forces to speed it up or slow it down, the final velocity at the end will also be 3 meters per second. Remember, this is only in the X direction. And remember, this is due, the fact that the final and the initial are the same is because acceleration is 0 in the X direction. There is nothing in the X direction to speed it up or slow it down. There's no forces. Time is unknown, and X is also unknown. Now let's go into the Y category. The Y category completely looks at vertical. Do not think about X anymore. What is the initial velocity in the Y direction? Well, since the object was projected off the table horizontally, there was no velocity in the Y direction. There will be Y velocity later on as time goes on, but initially, when it was initially projected off, there was no Y velocity. Final velocity in the Y direction, we do not know. It's a question. Now, acceleration is in the Y direction is going to be due to gravity, and gravity's acceleration is 10. We, however, need to know, is it positive 10 or negative 10? And it depends on which way you make positive. Do we want to make up positive or do we want to make down positive? In these kinds of problems, in projectile path number 1, you want to make down positive. And the reason why you'd like to make down positive is because everything is happening down. The ball starts here and it just goes down from there. It doesn't magically jump up in midair. So we don't have to worry about the velocity or the acceleration ever being negative if we make down positive. So because I made down positive and my acceleration points down, that's why my acceleration is also positive. Time, we do not know. Time is the only variable in the x and the y column that are going to be the same. And then finally, what is our y displacement? How far does it go in the y? Well, we know the table is 1.2 meters high. And so it's 1.2 meters displacement. Now that we have it all analyzed, let's go ahead and solve the problems A, B, and C. For letter A, it's asking for how long is it in the air for. Think about it. Which column, X or Y, would dictate how long something was in the air for? The answer to that is the Y column. Because think about it, if it wasn't for gravity and gravity's effect on the ball, it would never hit the ground. It would just keep going in the air forever. And so it's the Y component, it's the gravity component that actually is affecting the ball hitting the ground and thus limiting its time. So when we're asked to solve for time, we're going to use the Y column. Okay, when I think about which variable or which equations have y in them, or excuse me, time in them, there's two equations that pop to mind. There's this equation, v final equals v initial plus at. And then there's this equation, y equals v initial t plus 1/2 at squared. Both of those equations have time in them. We just have to make sure we pick the right one that we know enough information for. Since I don't know what final velocity is, I can't use the first one because there's too many unknowns. So instead, I'm going to use the second equation. Let's start plugging in the information that we know. My y is 1.2 meters. That's equal to, now notice this, the initial velocity is 0 in the y. So that makes this whole term cancel out. So really we're just left with 1/2 the acceleration, which is 10 meters per second squared, times time squared. If we solve for time, I'm going to do 1.2 divided by 1/2 divided by 10 and then square root that. My answer is approximately 0.489 seconds. All right, now let's look at question B. Question B asks, how far away from the table will the ball land? So it's asking for this distance right here. Since that is asking for an x component, we now need to use x values. We want to know how far horizontally did the ball go. Extend this page a little bit so we have some more space. Okay, so now what I'm going to do is I'm going to look at my same formulas, but I'm now going to look at x values. When I think about which equations have x in them, there's two equations that come to mind. Here's the first one, v final squared equals v initial squared plus 2ax. And then there's this equation, x equals v initial t plus 1/2 at squared. We just used this one earlier, but for y values. Now, it may be tempting to want to use the first one. After all, you say to yourself, I know what final velocity is in the x direction. I know initial velocity is in the x direction. And I know acceleration in the x direction is 0. So I can solve for x. But here's the problem. Remember, the acceleration in the x direction is 0. So if you plug 0 into this equation, that will get rid of this whole term. And that term includes x, which we need to solve for. So we cannot use the first one. So instead, we're going to end up using the second equation again. But now what we're going to do is we're going to use it for y, or excuse me, for x values. So if I want to know how far something goes x, I need to use the initial velocity in the x direction, which is 3 meters per second, times the time it's in the air for, I now know, which is 0.489 seconds. And then notice here, plus 1/2 at squared. The acceleration in the x direction is 0. So that gets rid of this whole term. So really, my distance in the x direction is just equal to the velocity times time. So if we do 3 times the time of 0.489 seconds, we get the x distance is 1.47 meters. Finally, the question that asks in letter C, what is the v final in the horizontal? What is the v final in the vertical? And then what's the final velocity overall? Remember, we've already covered that when the ball hits the ground, it's going to have x component of velocity, y component of velocity, and those two together will give you your final velocity resultant vector. The x velocity, or horizontal velocity, we actually already know. It's 3 meters per second, because it doesn't change. The y velocity, on the other hand, we need to figure that out. It's a question mark right here. We don't know what the y velocity is, but we can figure that out. Okay, let's think about it. Let's pretend that the ball is not rolling off horizontally, but it's just being dropped from the table. The y velocity will still be the same, regardless of whether we just drop it or it projects off horizontally. So let's figure out what that would be. I know the initial velocity is 0 in the y. I know the acceleration is 10, and I now know that the time is 0.489 seconds. We solved for that in A. So what I can do is I can use this equation right here. V final in the y is equal to V initial in the y plus acceleration in the y times t. The final velocity in the y is going to be equal to 0 is the initial velocity plus acceleration is 10 times the time of 0.489 seconds. My final velocity in the y direction is 4.89 seconds. So I've got my x velocity over here is 3 meters per second. I've got my y velocity is 4.89 seconds, and that's going to be this side. And now to find the final velocity period, we can solve for this vector here using the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. My a squared is 3. My b squared is the 4.89. Set that equal to c squared and solve. For my c, that'll be my final velocity. So 3 squared, which is 9, plus 4.89 squared, square root of that answer, and that gives me my final velocity of approximately 5.74 meters per second. All right, we got a little bit of time left. Let's go ahead and look at the next problem. An object is projected horizontally off of a 9-meter high cliff. The object lands 5 meters away from the base of the cliff. A, how long was the object in the air for? B, what was the initial velocity? And C, what was the final velocity? Remember, it will have x and y components. So let's first draw a picture, just like I did before. This problem is a little bit different based on the information it gives me. I know this object is fired off horizontally. I know the cliff is 9 meters high, and I know the object lands 5 meters away. So the object takes a pathway that looks like that. Now I'm going to go ahead and make my XY table. All right, let's go ahead and start plugging in some information that we know. The x velocity I do not know. The problem doesn't tell me. Therefore, I don't know the final velocity either, but I do know that they will be the same because acceleration is always 0 in the x direction. I do not know time, but I do know the x displacement. The x displacement is 5 meters. For the y column, I do know that the initial velocity is 0. I know that because it's fired off horizontally. Anything fired off horizontally does not have an initial y component. The final velocity is unknown. The acceleration is 10, and I'm still making down the positive direction, and therefore my acceleration is positive 10. The time is a question mark, and the y displacement is 9 meters because the cliff is 9 meters high. At first glance, it seems like we don't know a lot of information, but we can figure out some information from this problem. All right, the first thing I want to do is I want to figure out what is the time. Remember, time is going to come from your y values. So if I look at my y values, I have a distance and I want to figure out time. So I'm going to use this equation right here. Remember, since the initial velocity for the y in this case is 0, this term cancels out. And so I end up getting y, which is 9 meters, equals 1/2 the acceleration, positive 10, t squared. If I solve for t, that will give me my time this object was in the air for. 9 divided by 1/2 divided by 10, square root that answer, I end up getting for t 1.34 seconds. Now the time is going to be the same for both x and y. So 1.34 seconds in the y and 1.34 seconds in the x. Now the second question is asking me what was the initial velocity? All right, so it's asking me to solve for v initial in the x direction. The reason why I know it's in the x direction is because it's fired off horizontally. So the horizontal or x component of velocity is the initial velocity. There is no y component. So since I'm asked to solve for an x velocity, I need to use x values. What I'm going to use this equation. Because remember, when I use this equation in the x direction, the acceleration will always be 0, and so that term will always cancel. So I will always get x equals just v initial times t. I know the objects traveled 5 meters in the x direction, and that's equal to the v initial, which is what I'm solving for, times the time, which I now know is 1.34 seconds. That will get me my initial velocity in the x direction and as a whole, and that's going to be 3.73 meters per second. So that is my initial velocity in the x, and it's also my final velocity as well, because velocity never changes in the x direction. Finally, C asks, what was the final velocity? Once again, remember, final velocity is a combination of x and y components. So let's go and extend the page and do letter C. If I think about what the object's velocity or motion map would look like at the very bottom, it will have x component, and it will now also have y component due to the increase in gravity. If I add these vectors together, tip to tail, I can draw my resultant vector in just like that, and that's what it's asking me for. So my I'm going to draw that a little bit larger over here. My x velocity never changes. That's the 3.73 meters per second that I just found. The y velocity is unknown to me. I do not know what that is. However, I'm going to use this equation to figure out what the y velocity is finally, if I know the initial velocity and the y acceleration in time. Final velocity in the y is going to be equal to 0 plus the acceleration of gravity, which is 10, times the time that I know is 1.34 seconds. That gets me my final velocity in the y direction is 13.4 meters per second. So that's what goes right here. So now I know the A and the B. I need to find the C, once again using Pythagorean theorem. 3.73 squared plus 13.34 squared equals C squared. If I perform Pythagorean theorem, I'm sorry, this should not be 3.4, this should be 4. Okay, 13.4 squared. If I do the Pythagorean theorem, I end up getting for my final velocity approximately 13.9 meters per second. Okay, for timing's sake, we're going to do these next two problems, but I'm just going to allow you to freeze the screen and then go ahead and hit play to reveal the answer. So pause the video right now and do this problem, and then hit play to reveal the answer. All right, here are the answers for these two questions. I've also shown work there as well, so you know what the correct equations and work would look like. We have one more problem. Go ahead and try this one. Once again, pause the video, work this out, then hit play to reveal the answers. And here are the answers here. Notice the work is the same setup as the last problem we did, just different numbers. This concludes the video on projectile path number 1.